Welcome back. So, hope you had an opportunity to stretch your legs a little bit. I know it's been a tough day. Now it's my great pleasure to introduce Scott Newbern, Vice President and Chief Technology Officer at AeroVironment. Now, Scott's bio is on the website, but not only is he Vice President and Chief Technology Officer, but he also leads McCready Works Laboratory. Now, I think Tom Vanek talked about that earlier today. So the laboratory was named after the founder of the company, which is focused on continuous innovation. So I'm looking forward to listening to Scott's comments and trying to get a feel for where the industry is with respect to autonomy. So Scott, if you're ready, we can get going.
Good.
Share your screen. If you have any slides. Perfect. And they're up.
Yeah, and so comms check, good. You guys can hear?
Perfect. Thank you so much.
Okay. Thanks, Wasim. And again, thank you to AUVSI and New England chapter there for giving me the opportunity to speak today. It's exciting to talk about this. Actually, robotic autonomy is very important to us, and actually, we're sharing some things here that we haven't shared in public. Some of the videos are a little more on the engineering side of things, but I think it'll be fun and interesting for everyone. Just for those of you who may not know who AeroVironment is, we're actually celebrating our 50th anniversary this year. And we're a leader in the robotic system space. We basically pioneered and invented, so to speak, a couple of classes of unmanned systems and brought those to market. We're primarily based out of California, but for those of you who are in New England, we have a New England Innovation Center. Hopefully you guys saw Tom Vanek speak earlier today. He leads that center, and we're excited to be in that part of the country now as well. I think it presents great opportunities for us to extract talent and collaboration in that part of the world. So actually, hopefully, if you didn't see Tom's brief, go back and take a look at it. He did describe a little bit of the history of AV, and you can see some of our historical products and comments in that. This is our current product portfolio. And we're most well known for the small UAS family of systems, Wasp, Raven, Puma, those products there. But this also includes Switchblade, loitering missile systems, family of systems, and Vapor rotary UAS, and Quantix, which is a hybrid VTOL solution that actually does autonomous mapping with no comms, so it's comms independent. If we look up to the heavens, we have our solar high altitude platform system, sort of a surrogate satellite type application. And then our most recent additions, actually, Telerob unmanned ground systems with the Theodore and Telemax products. We just brought them on just before the holidays. And then very new news, we just announced yesterday afternoon incorporation of Arcturus Group 3 UAS products, Jump 20 and T20. And so we're really excited to have those guys on board, help fill out our family of systems, and really it leads into our future state vision. Those guys are going to help take us there as well. And this is kind of one way to think about our future state vision. Some elements of that. We are a robotics mission solutions provider. We work at the crossroads of future defining capabilities in analytics, sensors, robotics, and connectivity. The items here are kind of some key elements that help drive us towards the future state, but really these in turn help drive our mission solutions that allow our customers to go do new and great things. But the key element is autonomy. What really helps us advance our capabilities to this next condition is autonomy. And at least in the last 4 to 5 years, It's our #1 area of investment in our IRAD and our technology developments. And that's, again, to get us towards this future state vision. So for today, I thought it was worth describing autonomy, at least the way we think about it. And there's a lot of definitions floating out there. For us, it really comes down to this. You can think of it as one word, as independence, but it's contextual. So for robotic systems, it means they must be safe. They have to be cognitive, dynamic, and operate within the system, which really means, they have to understand their own limitations. They have to understand their role within a mission and what the roles of others within a mission is. And that helps them, provides them abilities to sense and perceive things that allow them to dynamically change within a scenario or mission. And I think the last item there, the system, is very important. We often think of a robotic system as a platform, but the system itself is made up of multiple components, being a system, sensors, analytics, all of those elements together. We can stack those as systems of systems working together, and then ultimately a team, which that team always includes a human. And so the human is part of that system in the context of autonomy. And then, so thinking about levels of autonomy or increasing autonomy, we always say, oh, we want to increase our capabilities or increase the level of autonomy of the system. I also like this model in thinking about that because of the contextual side of it. This is a contextual capability model for autonomy. It not only includes this axis of independence, but also mission complexity or mission context, and environmental complexity or environmental context. So in this axis, the further you get away from the origin, the more autonomy, the higher level of autonomy you've introduced. And then we can lay that out on a linear scale here and go from left to right, and lower level of complexity and autonomy to higher levels on the right. And if we just think about some examples there, towards 0 would be something like a tele-operated system or a remotely piloted system that is almost more, stick to surface. Then you move a little bit to the right as you add GPS navigation, and then maybe you add a geofence around the GPS navigation. And so you're increasing as you move out. In increasing complexity. The key element, though, is that progression in our minds is increasing the perceived context, perceptions within the context, and increase machine cognition. And so those are some of the what driving some of the things we're working on. So before I talk about some of what we're working on now, I just want to hit a little bit of kind of where we stand today, or kind of a little bit what we have done in the past. So I mentioned several of these systems when I introduced our family of systems. And we've always thought about autonomy at AV. In fact, I think, it's on the lower side of that, GPS navigation, but I believe we actually were the first to deploy a GPS guided system in a UAV. And I can't find enough public records to know that that's true. And there may be some non-public records, but it's been part of our core from the very early days to always introduce this concept across everything we're doing. But if we just take some examples here, Quantix, for example, is a mapping solution, dedicated mapping solution, very simplified user interface. And it can go perform its entire mission after the user decides what it should do. It performs that mission, collects the data, stitches the maps together, produces the result, and it does all that without communications. Puma in Puma, we've had a moving target tracking system, which uses artificial intelligence as part of its algorithm. And I think we introduced that in something like 2006. And we've continued to proliferate that. So they're Switchblade, the terminal guidance on Switchblade has always been GPS independent. It's a vision processing based system. So the point is, these systems are deployed worldwide in large quantities. They represent millions of flight hours, and it gives us a solid basis of qualification and a history of robust operational autonomy, and a basis on which to deploy new autonomy. So if we think about things that we want to progress and things where we want to head, there's a number of capabilities here. Things that we're working on, things we want to do. It's probably not a comprehensive list. Introducing a framework of autonomy and architecture that we can apply across that entire family of systems that has an open API so that we can introduce third-party products, or we can take our system and add it to a larger level system and integrate. Secure update capability is always a key element. Task and mission-based user experience, so that, kind of like what Autonomy was talking about before, just before this. There's a number of elements here, but ultimately all of these drive towards increasing autonomous capabilities, moving up those levels of autonomy that we talked about, if you will, to provide new solutions and mission capabilities for our customer that allow them to have reduced cognitive load, operate in A-to-AD environments, have improved persistence, improved speed and agility, introduce greater team level operation, or swarms, if you will, those sorts of things. So now I'll give an example of how we're doing that. This is Park, our Puma AVICORE retrofit kit. So AVICORE is what we've called our autonomy architecture that will be introduced across our family of systems. And within Puma, this is actually truly a retrofit. The fleet of Pumas that are out there, this can be added in to introduce additional capabilities in visual tracking, GPS denied behavior, and communications independence, as well as an open API playground that we can introduce third-party solutions as well. So to give a few examples of what we're doing there, this first video is a mission where we asked the Puma to go find a particular white truck. Should be playing the video. Find the truck. So the mission was pre-programmed, and the operator just launched the Puma, and everything else was done autonomously. So the Puma contained itself within a safe airspace boundary, found the white truck in the area. I didn't want to bore you with that process of showing the video. Doesn't confuse other white vehicles with the truck that it's following, follows the truck through evasive maneuvers, and tries to predict where it's going to keep up with it, because the truck probably at times can go even faster than a Puma could. And all of this without GPS, so no GPS during this operation, and no communications back to the operator. This is a second example, also using a Puma with a Park-like capability. In this case, it's a fire monitoring, mapping, detection, monitoring, and mapping mission. And this we've integrated into an ATAC controller. So the Puma's flying, there's a report that there's a fire in an area, and that triggers the Puma to go towards the area where there might be reported a fire. In this case, we're using a smoke generator rather than a real fire. And just for fun on the display there, as the Puma is searching for smoke and fire, we have a little trigger there that says, I detected smoke, or there's no smoke or fire. And then it keeps searching. Once it finds it, it's done a scan in an area and says, okay, I'm adjusting my flight plan and my course to go start mapping this, geolocate the fire and smoke, and persist. So continue to monitor the fire, predict where the fire is going, stay ahead of the fire line a safe distance. And this is more of an engineering display, but you can see this is the algorithm in operation where the flight path is staying a safe distance away from, not only a safe distance away from the fire line, but also keeping the fire in view as it's expanding and moving. And then as you can see, we continue to geolocate the fire and smoke and update the operator display. And let's see, I need to get out of pointer mode. I'll try to speed this up just a little. And so I really want to emphasize here it's often difficult to show what's going on in autonomy operations. And I think this is a good example that we talk about sending drones in to be used for firefighting operations and things. Well, this is what an operator would see. So these are prescribed burns we participated in. There's a thermal camera view, a long wave thermal, so we can see fire through the smoke a little bit there, or hot spots anyway. So what does an operator do with this? If you have a traditional UAV, a traditional drone, I see the smoke, oh, there's a road there, I can at least call in and say, hey, it's above this road. We've actually done some of this with our local firefighting agencies, integrating into Google Maps and dropping pins and things so you can sort of start manually mapping out where a fire is. But this is really what's going on. In our case, this is a sample of what the EO imagery is doing when it's being processed. So we do something called semantic segmentation, and it allows you to basically take the smoke and register every pixel of smoke or fire and geolocate that, and that allows us to place it on a map. And I don't know, there's a number of missions like that where we're operating the monotony of operating a EOIR platform and just staring at either nothingness or hoping that you're not missing something is just awful. This last example is not a Puma. This is a collaboration we have with General Dynamics Land Systems and Planck Aerosystems. There's a multi-rotor, which is integrated into a manned ground platform. Has the capability to autonomously launch and recover, even on the move. The mission that we have enabled is really a wingman operation. So there's the operator display. And in this case, there's not a lot of autonomy in the video. In this case, it could certainly be applied, but he's operating it more like a periscope. So he's manually steering it around to look for things, but the autonomy here is in the wingman operation, and that the multi-rotor is maintaining its altitude and relative position against the ground vehicle as it's moving. Okay, so finally, I want to talk a little bit about challenges in this space. We've seen a lot of things today. This conference has been great, by the way. There's a lot of discussion on autonomy and progression there. I think there's still some challenges in where we want to go, and these are a few of them. Again, not comprehensive. I think hype is actually quite a big one. I think hype can be good and bad. The hype around autonomy and AI has been probably beneficial in that it's inspired lots of investment, lots of new companies, lots of work going on in pursuing autonomy and AI. But I think it's also inflated expectations so that when we go to exercises, when we go to operationally relevant performance of these systems, it maybe doesn't live up to what those expectations have been challenged to be. And that can be disappointing and create disillusionment and, you know, maybe lack of focus and continuation of the follow through part of what we need to have happen. And there, I think it's just perseverance, right? We need to make sure that we continue to work and progress and continue to keep this at the forefront to break through that disillusionment. The human integration piece is one that I think, again, there is work going on here, but I think there needs to be more work, more investment. This is the interaction between the human and the robotic system, not just at the user experience level. And I think the Autonomy guys who had the break right before this, they did a good job of discussing some of that. And they're making progress as well, by the way. But again, I think, you know, what a lot of the systems and a lot of the autonomy that we're generating can almost backfire on the cognitive load piece of what we're talking about, in that some of the systems and some of the complexity of the mission and the environment takes quite a bit of effort to get the robot system to understand what we're actually trying to accomplish. So how did I tell the Puma that was the white truck that I wanted it to follow and to go do that? And, you know, where was that airspace boundary? How did it figure that out? And I don't know, maybe another example, more forward looking, would be, you know, how do I tell R2D2 to take this message to Princess Leia and don't get into trouble, right? And so I think there's still a lot of work to be done on that interaction, especially as our robotic systems become more independent. They become more human-like. And if you think about how difficult it is for humans to communicate, we have the same problem now with our autonomous friends. The transformational mission operation and deployment is I truly believe we've seen UAS be disruptive capabilities that have come about in both military and commercial and enterprise spaces. Anytime there's transformation, it often means that the way a job is performed or the way we get things done needs to transform as well in order to take advantage of that new transformation. And I think this is a big challenge in you know, how we adapt. And I think it takes strong leaders. I'm really getting at more of the military side of things. I think there's a lot of work going on in certain areas. But, you know, we need leaders on the military side to stand up and say, yes, we are going to transform the way we do things. We're going to change the force structure if we have to, in order to enable these new capabilities that give us a overmatched capability. And I think there's an example there I can share as well. And some people have probably heard it before, but in 2008, we had a chemical mapping payload that could be introduced to any Raven. So basically a payload you plug on to any of the 1,000 Ravens that have been deployed. And it also had interfaces into a network system, and other sensors could trigger this, but independently, you could launch this and it would map 8 different chemical agents, detect the plume, follow the plume, map it, predict where it's going, and, you know, all pretty much without operator interaction. Yet today, the primary way that our soldiers detect chemicals is by holding a sensor in their hand. And so if we think about that kind of capability and why it's not out there, I think it has to do with the ownership. Who owns the mission to detect chemicals? Who owns the mission to operate UAVs? How do we get those guys talking and adjust how we do those missions in order to take advantage of these new capabilities? And then last is V&V certification. there's great work going on with UAM and in the automotive driverless car industry. But I think at a lower level, when we look at some of the capabilities that we introduce in this higher level of independence with these systems, they will be so adept at adjusting to their context in environment and mission, as we talked about before, that it creates a real difficulty in qualification, I believe. And so I think we need to, both as an industry and a government, we need to work on enhancing those capabilities and how we actually certify and say, hey, this thing, we can reliably say that this thing is going to do what it says it's going to do, right? And then finally, that's kind of, I don't want to get off the stage with sort of the negative, where are the barriers? So I think all of those things can be overcome. I'm certain we will overcome those with the kinds of collaborations, the people that have talked today at the summit. We're going to get there, and AeroVironment's going to make sure that happens as well. So, and with that, I guess we can move on to questions. I actually hadn't tracked time. How are we doing?
You've taken a lot of time, Scott, but it was good. It was good time. It was good time. So
okay.
You raised lots of questions for me, and other people are throwing in some questions too. But, you know, transformational, that comment you just made about transformational and who owns the mission. So that really goes back to, why do we need the truck, right? And who's in charge of the truck, and why do we need it to, you know, what kind of mission is it? Is it ISR? Is it, as you talked about, plumes, or is it something else? So that's a bigger sort of ConOps doctrine type question, don't you think?
Yes, definitely.
Okay. With respect to, you know, you talked about autonomy, and you've talked about, okay, we have this and many products in our defense lineup, but then we have these products in the civil lineup, right? So what sort of autonomy demands are you seeing from each of those sort of markets?
Yeah, I think so. There's crossover, like, yeah, I think we think of it that way, just because, you know, we tend to divvy up our markets and think of them like that. Most of our historical product development has been aimed at defense. You know, that's kind of where we got our start. But there are crossover products. I think Quantix is a good example. And I would say it's maybe just more of a tailoring of the capability. So, you know, Quantix actually started out as more of a commercial product for us. Yet the fundamental autonomy characteristics, the ability to manage its own airspace and develop its own flight plan, works equally well in either of those markets. And it's, I think a lot of what I described earlier, I think applies across multiple markets. I don't think there's really any major discriminator. It's more, you know, what is the mission that's trying to be accomplished? And, you know, the Quantix example, there's a direct parallel, right? The military mission is mapping, the commercial mission is mapping, right? So those capabilities kind of overlap. And I think, I don't know, it's just a mix of what those missions are, I think, right? And there's overlap across the board. If we go to our high altitude platform, you know, our current focus there is more of a commercial mission providing telecom services from the stratosphere. But the station keeping and constellation management that you would need for that fleet is just as necessary from an autonomy standpoint, whether it's a military mission or commercial mission.
Fantastic. So So Scott, unfortunately, we've run out of time. So let me say a few things. One, thank you for putting this together. Thanks for giving us an update on what's happening to, at AeroVironment with respect to autonomy, but also a few other things. Thanks for stepping up to support the AUVSI New England chapter.
Sure.
So that was really good. But also now the region, right? So we know you have a small footprint in KRI and you're moving out with a larger regional footprint. That's fabulous for the region. So thank you so much from an AeroVironment perspective.
Yeah, I think we're close to 30 or 40 employees there now, actually.
Right. Yeah, but I understood there's a new facility coming too, right? So
yes.
Yeah. So I look forward to that. And your what's it called? The McCready.
McCready Works. Yes.
Is that purely virtual? Is there a real location for that?
Oh no, it's virtual. It's roughly what most people might call a business unit, I guess, is the way you think about it. Yeah.
Okay, fantastic. All right, so let me say thank you again. I don't want to take any time out of the next session, but
Okay.
Thank you for joining us. Thanks for presenting, and I look forward to interacting with you outside.
Thank you.